Oh, hey guys, it's Tuesday the 10th, right? I think. For your warm-up, we're going to talk about domain real quick. So, for this guy, remember domain is the, oh, you know, why do I have to say it? Domain is the denominator. Sorry, I didn't mean to hit pause while I was changing pen colors, but I did accidentally. Alright, so domain comes from my denominator. I take my denominator, 3x to the cube plus 8 is equal to 0. Subtract 8 both sides. Then I have 3x cubed is equal to negative 8. Now I divide by 3, divide by 3. Then I have x cubed is equal to negative 8 thirds, right? Negative 8 thirds. Then I take the magical cube root. Cube root, x is equal to the cube root of negative 8 thirds. And I can have negative cube roots. They're not imaginary because when you cube something, you can have a negative, right? Like if I have negative 2 times negative 2 times negative 2, which would be negative 2 cubed, right? Negative 2 cubed. That gives me 4 times negative 2, and then 4 times negative 2 is negative 8, right? So I can get a negative answer when I cube, so I can take the cube root of a negative number. It is not imaginary. It is a real number. I know you're excited. I can just tell. All right, so we're still talking about rational functions. This is talking about x, y intercepts, asymptotes, and holes, and graphing things, okay? We will work really hard on graphing when I get back. I know you just can't wait. Okay, so for number 10 on your worksheet, we're only looking at number 10 on your worksheet. Remember, A, B, C, and D are what we did last week. So we're going to look at holes and vertical asymptotes. And if you don't have that from last week, you need to go watch the video from last week and write all that down, the work that goes with that, not just the answers. Remember, I have a hole when a factor appears in both the numerator and the denominator. Do I have a factor in both the numerator and the denominator? I check B, my factored form, and oh wait, what do you know? It's right here. So I have x minus 3, right? We'll set that equals 0, add 3. There is a hole at x equals 3. So E, there's a hole at x equals 3. And then for vertical asymptotes, remember that's my domain restrictions. So F, when x equals 3 and negative 1, I have vertical asymptotes. So I have, if this was graphed, 1, 2, 3, 1, 2, 3, 1, 2, 3, bear with me, I know it's pitiful. And x equals lines are where x equals 3, right? So x equals 3 here. That's not what I meant to do. X equals 3 right there. And x equals negative 1 right here, right? So this graph has those dotted lines, those dotted asymptote lines here and here, because they're vertical asymptotes, right? Vertical asymptotes. All right, next one. I almost said questions. I don't know how I was going to answer your questions, but anyway. So looking at number 12, same idea. A, B, C, and D are done. We did those last week. We're talking about holes. We're looking for factors that are both the numerator and the denominator. Do we have any factors that are in both the numerator and the denominator? No, we do not. So E is none, and O-N-E. None. No holes. All right, my vertical asymptotes are my domain restrictions. So for F, x equals negative 2, x equals negative 4. You can write it with the comma or you can write it like this. It doesn't matter. But you do need to know that that means that there is a vertical asymptote at x equals negative 2 and x equals negative 4. So there's a vertical asymptote here and a vertical asymptote there. This graph is going to have humps like that. Can I undo that? Nope, I have to erase it. Like that or like that or something similar, all right? Make sure you get all this looked at. If you're struggling or you're really lost, I posted 2 links to Khan Academy and another website to help with some of this. There's also information about horizontal asymptotes that we have not talked about. It's got to do with the coefficients. So I should see you all tomorrow. Have a fabulous evening.